sustainability challenges and how cities are related to climate change. So that's a main ingredient of my talk this morning. So before we start and go into details, let's frame a little bit the scene. And I took this image here from the 6 assessment report, so from the synthesis part. And what you can see here is that the planet is still heating up, and in 2023 we have already approached the 1.5 degree threshold. So a lot of people are talking about targets, but it is not really a target, it's a threshold. Yeah? So this is something what we have to make clear indeed. So in 2023, we approached this 1.5 degrees threshold. That means, in other words, humanity for the first time ended up in a range of very, very serious climate change. And this is something what will indeed proceed, and how we and also our relatives would suffer from this, you may see here on this slide. Yeah? So when a child today is born, so in 2020 here, so she or he will be 70 years old in 2090. And if we proceed as we're doing it in the moment, so we are still on the business as usual track, they have to live with a very high emission scenario and consequently also with a very high global warming. And what we see in the moment is that, of course, the temperature to the global warming is accelerating even faster than scientists have expected it. So, for instance, the European continent in particular is warming up twice as high as estimated. Yeah. So, and this holds also for some other regions. So, for the Himalayan Hindu Kush region, this is also observed in a few more regions as well. So these are really warning signs, and the question is really whether we are able to bend down the emission curve in the future or not. So this is a challenge we have to face, and cities play a particular role here because cities became the favorite settlement style, so to say, and how this was developing. You may see here by this animation, which started around 3,500 years before Christ. So you see that at this time we had very favorable climate conditions in the mid latitudes, and no wonder at this time most of the cities were emerging there. But then we made a lot of innovations, so technological innovations. And what you will see in a few seconds is that that urban settlements were distributing more or less over the whole planet. And this is a situation in which we are still, and there are no signals that the migration into cities could be stopped because of many advantages that people see in cities. So normally you can gain more income in cities. You have better medical service, and a lot of other aspects need to be taken into account here. Yeah, and as you see already, cities are spreading more and more. And at the end, you could have the impression that the planet is only full with cities. Of course, it's not the reality. The land cities are using is around 2 to 4% of the total land surface, but nevertheless, cities are attracting huge amounts of materials. So this is the end of this simulation now, and this is more or less so in the situation in which we are still in the moment. And if you look on that, what will happen in the next decades, you have to take into account that the global urbanization is already responsible for 70% of the global emissions. And when you look on the absolute and relative shares of residents in cities, you could say that between 1950 and 2015, we have seen already a considerable growth. So from 30% of the global population living in cities up to 50%, a little bit more. which were living in cities in 2015. And if you would make a simple thought experiment here, you can estimate that per decade in this time we needed to construct new urban infrastructure for around 460 million people per decade. Yeah, so that was happening between 1950 and 2015. So if we look into the UN statistics and of course population growth, you can forecast very, very easily. We estimate that around 2050, almost 2/3 of the global population will live in urban centers. So, and if you would do the same thought experiment, this would imply that per decade we then have to build around 740 million infrastructure for 740 million people per decade. And of course, here we have to ask the question, how could this be achieved? How could this infrastructure being built? So when we follow, let's say, traditional styles of buildings, but of course, so we cannot stop the in-migration, and the UNEP, for instance, estimated that this will mean that we would probably need 4 billion new dwelling units by 2050. Yeah? So this is a huge number. And the question really remains, okay, from where should all the material come from? First point. Second point, are we able to do it in a sustainable way so that we can reduce the emissions coming from cities considerably, so that we can also heal in parallel also the climate crisis somehow. So that's an open question. Yeah, looking a little bit more detailed on cities, we can say that cities are rather inefficient. So this holds for the emissions, but this holds also to for a lot of other for instance. And we have also a high lifestyle normally in cities. So these numbers came from the Ellen MacArthur Foundation, for instance. They said, okay, that 20 to 40% of the energy used in buildings can be saved when we would construct them in a much better way as we're doing it in comparison to today. So cities are not well organized when it comes to mobility, for instance. So in any country or across the world, we have a loss of up to 5% of the GDP due to traffic jams only. So this is also not a small number. And when it comes to the mobility in general, so 30% of the resource consumption is related to mobility. And then also 90% of the air pollution, for instance. Waste production is another aspect here. So in other words, cities are not really sustainable. Sorry. What I will do in the next minutes, I will focus on a particular sector, namely on the construction sector, because the construction sector is one of the key levers which may help us to heal the climate crisis in the future. And how this could be possible, I will show you. But before we can enter these steps, of course, we have to think about circularity. Circularity is in any case the key. Yeah? So circularity has also economic aspects. So they can dive into circularity. This indeed will reduce the carbon footprint, but not only the carbon footprint, also the material footprint of cities. So circularity can strengthen local value chains, because circularity ideas and methodologies and concepts you will normally apply on a more local scale. So circularity is also fostering innovation, because managing circularity needs complete new business styles. Yeah? And this comes, of course, also together with new business ideas. So circularity is a business of the future, but unfortunately, yeah, circularity has not been really implemented in many regions around the world, even not in the developed world. So in Germany and in Europe, we are quite good in collecting glass and paper and steel, but that's it, right? Okay. Yeah, so and what is the outcome of all our construction industry? So you see here some numbers. So and I will now refer a little bit to concrete and cement. So we have actually, or still the situation that 20% of the humanity still consumes around 80% of the resources. So this needs to be changed indeed. And the wealthy countries either need to dematerialize the technical basis of its of their prosperity, or to increase resource efficiency by at least a factor of 10. So this is indeed a challenge, but let's see how this is possibly feasible. Another interesting aspect here is that the global human-made mass is already exceeding all living biomass by 10%. So in other words, we are transforming the planet into an artificial environment. And one element of this transformation, so to say, is our infrastructure. You see it here by the example of Manhattan, so that's New York. And yeah, and the basis of all this is just one material, namely the cement. So cement was invented by the Romans just some 2,000 years ago. So they called it opus cementitium. And yeah, so that they were also building some nice infrastructure with the help of it here. So this is the Pantheon in Rome, a building which is almost 2,000 years old now. And you see the ceiling here. So this is a cupola, still one of the biggest cement-based cupola without steel. So it was made from the opus cementitium. So interestingly, so opus cementitium of the Romans was somehow different to that what we are using in the moment. Yeah. So they used volcanic ashes as main component. So they took it from Pozzuoli. So this is nearby Naples, a region which is in the moment which shows in the moment a high seismic activity. And from there, they took the so-called puzzolans and they mixed it into the opus cementitium. And this was a binder at this time. So what we are doing in the moment is, so we are crushing calcium carbonate from the rocks. Yeah? So we are crushing it, um, putting it into rotary kilns, and then heating these rotary kilns up to 1,000 or 1,500 degrees. And what then happens is that one carbon dioxide molecule is separated from the calcium carbonate. It goes into the air. And the remaining is the so-called lime. So it's a calcium oxide molecule, and lime is today, so in modern times, the main ingredient of cement. I told you, so one molecule of lime is releasing one molecule of carbon dioxide. So overall, it's a huge amount. And when you look on 1 ton of cement, so around 600 kilograms of CO2 is released from the production cycle. And if you look on concrete, so concrete is a mixture of cement and sand and gravel. So each ton of concrete includes around or releases around 1/3, so 330 kilograms of CO2. So that's a huge amount. And if the cement industry would be a state, so then they would follow in the second place or in third place after China and the USA in terms of carbon dioxide emissions. But this is not all. So it's all this carbon dioxide emissions, of course, have a relevance for our global warming. But what we should also take into account is that we need to utilize year by year 40 gigatons of sand and gravel. And this is what we have to extract from the nature. Yeah? So, and this was destroying all around the planet, beaches, river estuaries, and other highly valuable ecosystems. So this is also something what we need to take into account here. Okay, to sum up for the first moment. So what I may have shown you now is that modern urbanization creates a lot of problems. So here you see some examples of modern cities. So here on the upper left-hand side, you see the Unité des Habitations. That's in Berlin. It was built in 1957, so by the famous architect Le Corbusier. He was inventing a building style which was had clear lines, but later on it was called the style of brutalism, architectural brutalism. So nobody really wants to live in these kind of buildings anymore. But this style of brutalism is still present in some regions around the world. You see Kuwait, for instance, you see Dubai. All these cities can only survive because of the fact that they are using a huge amount of energy. So because they have also air conditioning there and of course a lot of materials. So this is something what we somehow have to change, because otherwise sustainable cities will not come true in the future. But this is something what we really need because of the problem that we are running out of resources, but also because of the accelerating global warming. Yeah. So if we really would take the climate challenge serious, then we have also to solve the global warming challenge or the global warming problem in cities, right? And we can either try to repair a little bit the climate conditions, or we can despair if we wish. Yeah? But despairing, I guess, is not an option. So once again, let us look on that, what happens at the moment. So these are the measured temperatures. So last year, no, in 2022, we had approached 1.2 degrees above the pre-industrial level. This is something which is now outdated. So in 2023, we approached the 1.5 target for the first time. And if we would approach, or if we would proceed with the global emissions in the way as we are doing it in the moment, so the business as usual scenario, so to say, we can expect global warming of +4 degrees. So the crux with this number is that this is the global average, and you may have heard that the oceans, for instance, have also an important role, because oceans are also cooling the global warming to some extent. When you live in very hot regions, so as in South Asia, for example, then you could expect that the temperature over land can even double. Yeah, so because land is heating up much faster than the oceans, for example. Yeah, and when you look on climate simulations, you also see it. Yeah, so the land temperature is always higher than that over the ocean surfaces. But let's stick on this 4 degree now, 4 degree temperature increase by 2200. So the question is really, are we able, or are we in a situation that we can bend down this curve somehow? So we call it overshooting. So because it's foreseeable when we look on the global carbon dioxide emissions that this will not be possible, but the question is how we can steer the system, the climate system, back to acceptable conditions. For this purpose, we have to accept for a certain time that we overshoot the maximum of necessary carbon dioxide emissions. So we know all this from climate simulations. So the maximum level of carbon dioxide emissions in the atmosphere should not transgress 450 parts per million. And we are almost there. So we are in a range of 420, if not 430 in the moment. So that means, in other words, we will transgress this value one day. And this is what we call overshooting. So this overshooting is in the discussion since, I don't know, at least 10 years, if not 20, no, 15 years, I would say. And if you look into the scenarios, into the emission scenarios, you may see the RCP 2.0 PD. So PD means peak and decline. Yeah, so we will in one time or on one day here in between 2000 and 2100, we will have a peaking of the emissions, and then we will be able to rapidly bend the emission curve down. Originally, we planned with a peaking in a time horizon which was or the maximum peaking was planned for 2050 and 2000, or between 2050 and 2060. Unfortunately, this is no longer possible because of our own behavior. So we are still releasing too much emissions, and there, in the moment, there are no signals that the emissions will slow down. So that means, in other words, we have to do some recalculations, meaning that the overshooting maximum will be moved further into the future. But in parallel, this also implies that we have to accept a higher global warming. So let's assume, so this was the original time horizon which was planned for the overshooting, but now we are here. So an overshooting means that we have to deal with negative emissions. So what are negative emissions? Negative emissions means that we technically probably, so that would be one opportunity, take emissions which out from the atmosphere, which we had already released to the atmosphere. So that means overshooting. And with these technical solutions, we can then hopefully bend down this curve, and then the system will go back to, hopefully acceptable climate conditions. Okay, what does it mean? So what could be the role of the cities into these regards? I would say that climate-friendly cities, at least to some extent, are possible if we could bring them on the transition pathways towards a sustainable bioeconomy. So what means bioeconomy here? Bioeconomy means that we would invest some efforts in the utilization of bio-based construction materials, for instance. Yeah. And we should possibly, no, not only possibly, we should, of course, combine these ideas with the management of forests. So forests are increasingly under pressure because of climate change, because of global warming. So we see it in many, many places on the entire planet. So a lot of people, amongst or in the domain of ecology, so they are always arguing, okay, let's keep forests untouched because of the fact that they are already under pressure. This is still a controversial discussion. From my perspective, I think management of forests in the future is the only way, because the only way to keep them, so to say. Because of that, what we see in literature is that the acceleration of global warming, that ecological niches need to move much faster than they could in the past. Yeah, so that's a problem really. So because when you really want to keep forest, you have actively plant new forests in regions where the climate has been changed in the last decades. So in other words, we have to manage forests more actively. And that means in parallel, though, that we also can make use of the forest products. Whenever when we are managing forests actively, we should take into account that existing forests stores around 7.8 gigatons of CO2 per year, which is not neglectable indeed. But the question could be, okay, are we in a situation that we can even increase this amount somehow? Of course we can. So the first attempt would be or the first idea here would be that we use existing barren land, for instance, for afforestation. And on the planetary scale, we have around 0.9 gigahectare of land additionally available for afforestation. Unfortunately, this is a solution only on a longer time horizon, because forests need to grow indeed, and this would need decades. Nevertheless, forests are one element for combating climate change. The other element indeed could be the idea to deal with human carbon sinks. So what are human carbon sinks? So in the past, we were mainly looking on biosphere carbon sinks. So we discussed the forest now, but what are human carbon sinks? So we are talking here about carbon sequestration, for instance, so engineering CO2 into sinks, so under the ocean, for instance, and in other places. So technical solutions. So this is something what we should take into account. But as I said earlier, so we can also try to combine the forest resources or the global forests and the products we take from forests with some technical solutions. And these technical solutions could be an advanced architecture. So the idea is to use buildings as a global carbon sink. Yeah, and you see here, so this is actually this is an article which was published 2020 by some colleagues of mine. So John Chernow was part of it, and a few more other colleagues. So they came up with the idea that the carbon pool formation in the past million of years created our oil and gas resources. With the oil and gas resources, we were able to produce huge amounts of cement and steel, which helped us to do this or to undertake this construction activity, so building these high-rise buildings. And now we have to reconsider this strategy by thinking about bio-based materials. So the bio-based materials then would store carbon dioxide in the infrastructure, and this probably could be a help to mitigate global warming. Good. So timber buildings. So that's the idea. Okay, here's a mistake on the slides, but nevertheless, so timber buildings have been proven that they are very durable and very stable. And this is a story which we have learned over thousands of years now. So you see here one example. So the Horyuri Temple in Japan, which was built in 710. So some individual components are even older, so they were already used, so built in at the end of the 694. And this is the worldwide oldest building, modern buildings from today. So that's here from the region of Berlin. This is a multi-story and then multi family house here, which was built in central Germany. It has a very good energy performance. So you see here the end energy demand, which is around 12 kilowatts per square meter, which is almost nothing. And if you look from the outside on this building, you would not think that this is a timber building. It looks not like a timber building, but it is. Here you see a building from Austria, which is also equipped with photovoltaics and a heat pump. So these are examples from modern times, and depending a little bit on the construction type, each family house needs around 50 to 100 cubic meters of wood. You have to take into account here that also timber constructions might be, so this is something what I have heard from architects, might be a little bit more expensive than traditional buildings, but this price advantage is rapidly decreasing. So when you look on mass timber productions or mass timber construction, you could become immediately aware that this price advantage of traditional materials like concrete or steel is rapidly going down. Yeah, so this is something what's ongoing, and because of the fact that timber is a natural material, this is quite good indeed. Here you see some other modern examples. So this is in the moment here, so the Ascent MKE, that's in Milwaukee, is in the moment the highest mass timber building. It's in the United States, but it was not built by people in the United States, not but by people from Austria. And what they did is interesting. So there were prefabrication, all the modules in advance, namely in Austria, and then they dropped them on a ship and transported it into the US. So this is something which also makes creates some progress in terms of circularity. And here in Germany, in Central Europe, we're doing something similar. Here you see some images from Terhalle, which is a company in Ahaus in Western Germany. They're also doing the prefabrication in their industrial plant. You see here the walls, and the walls are being equipped with all the necessary electricity lines and pipes and so on, and you then can decide about your rooftop. You can make selections about, you can make selections of traditional tiles, or you can use photoactive tiles. And when it comes to the walls, you can also make decisions regarding the insulation material. So so you have a lot of opportunities. So this is something what's going on. And in Europe, we have in the moment some forest die out, so which is related, maybe related somehow to that what happened in the recent years. So because we had tremendous droughts. And the forest owners, they're lamenting about their economic business ideas, because they're saying, okay, we have seen in the past a lot of calamity timber, and this is something what they could in the moment only sell to combustion, to energy power plants, so they just burn it there for electricity generation. But you see here a combination of traditional bricks with some Lego type timber products, which you then can combine to a wall. And this is an innovation made by Trick Brick. So that means also calamity timber you can use for construction purposes. So that's an interesting development here. And when it then comes to a sustainable use, of course, we have to think about modularity. Modularity helps us to create a kind of a standardized, to help us with the construction on the basis of standardized building modules. And these building modules you can probably use even for a second life. But before we can do this, of course, we need somehow material passports, which can give us some information about the building module, so how it was used in the first life, so what are the physical properties of such a module. And this is something what I'm foreseeing somehow in the future, namely when we can develop further the blockchain technology, which is now used for cryptocurrencies, but we can use also the blockchain, for instance, for material passports. That's also possible. Yeah, so that means whenever we try to invest into the construction industry, we have to think about the valorization of building materials in ecological terms, in economic terms, but also in terms of socio-ecological dimensions. And we have to do it for any kind of material which we are using. And what I don't want to do here is, in the moment, this is not a pure pledge for doing only timber construction. Indeed, cement and concrete will remain for some purposes, but we need to become much more efficient in the use of these materials. And if we are able to use bio-based materials, then indeed we can even make a strong progress in terms of future climate protection. And when we look globally on the industry, so on the construction industry, we have even to state that the construction industry is in a very bad condition, comparing it with other sectors, for instance, so computer production, construction of aircrafts, and whatever you can imagine here, production of energy. So the construction industry can gain a huge amount of efficiency, and this is something what we should indeed what we should focus now. So sustainable buildings can only succeed if the consumption energy and resources is really reduced during the life cycle of buildings. If we only use sustainable materials, and if we can start with a real circularity, meaning namely that building materials can be returned to the material cycle at the end of their life. So we have to change this take, make, disposed idea to a real circular mechanism. So I mentioned now, or I was pledging a little bit for timber-based construction, but there are also other low carb and low energy materials, so which we can use. So here you see the clay. So clay has also a long-lasting tradition. We see hemp concrete. We can even use natural stone. So during my last trip to Bhutan in May, so that natural stone plays an important role there. Timber, we have discussed. Bamboo could also be an opportunity in Asia. And then also the combination of timber and wood frames could be an opportunity. So that means when we focus on the construction industry only, so we have some alternatives. These alternatives are very old, and we made good experiences with them. But what we have to do for a real sustainable city in the future, we have to combine things now with the advanced technologies which we have now at hand. This will bring us really to a different level. And that's another aspect. So timber buildings have also some further advantages. So timber buildings and also framed timber buildings have a very high seismic resilience in comparison to traditional materials. So this is well known, but not really mentioned so much or not well known amongst the architects. I'm a little bit astonished about it. Yes, here you see on the left-hand side a shock experiment done for a 10-story mass timber building at the University of San Diego in the United States. So they were increasing the shock energy up to 6.5, 6.7 on the Richter scala, and nothing happens with the building. Yeah. In China, so the Chinese Academy of Science did some similar experiments with a small replica from the Forbidden City, and they increased the shock energy up to 10.1. We have never seen such an earthquake on Earth with an energy of 10.1, and nothing happened. So the building remained. Only a few bricks were falling out of the walls, but that's it. So this gives us, so we have somehow forgotten that the good things which we have learned from the past. What we also know from timber buildings is that timber can mitigate heat burden, and this is something from which a lot of bigger cities are suffering today because of the concrete materials which have a high heat storage capacity. We can globally see that cities are have a higher temperature burden than the natural areas around. And the reason why timber buildings are better here is that timber has a lower thermal conductivity than traditional materials. So this is also something what we should not forget. Last but not least, fire resistance. So a lot of people have fears about the fire risk. So when we in the future would have more timber buildings in cities, but also in the US, they did burning experiments, as you see here, and they found out that 5 plywood-based cross-laminated timber have a fire resistance of more than 3 hours. So that's even more than concrete would need. So the fire resistance of concrete buildings need to be a little bit more than 1 hour. So that means, in other words, so you can do timber constructions in a way that they can withstand big fires. And then finally, global warming potential. So we have some examples for which we can compare buildings. So one is in Melbourne, so the so-called Forte building, which is in the harbor of Melbourne. And if you look here, so that they tried to construct it twice. At the end, they built only the timber base, but we have a full material list for this building here, and therefore we can calculate the carbon savings and also the carbon storages in the building. And the absolute difference is around 1,600, a little bit, 25 tons of carbon avoided and stored. So that means, in other words, 0.5 tons per square meter living area is stored in, or is avoided and stored in the building. So in principle, you can say 250 kilograms are stored and 250 kilograms are avoided. So this is something which is in line of that what other buildings is showing us here. So for instance, Södra building in Sweden, Stora Enso in Austria, and a few more. So that means overall timber construction could make a difference. So what are the energy needs per construction material? You see here, so how much energy we really need to invest in order to get some kilograms of construction materials out of it. And as you see here, so timber has the best performance when it comes to cement. So and also and plastics and steel and aluminium, also materials which we are using. So it goes almost to zero. That means, in other words, once again, so cities are quite inefficient in terms of material use, but also in terms of energy use. So the remaining question is now, do we have enough timber on the planet to do all this? And this is a calculation I did this year. Also, there are still some German words on it, but doesn't matter so much. What I did is the following. So I calculated, or it took from statistics, the existing forest area, multiplied it by the amount of forests which are managed in the moment. And then I calculated on the basis of some international indicators how much biomass each of a hectare of this managed forest can create year by year. Estimated the theoretical timber yield, and then I reduced this number, so 80% of the yield we only took out because of sustainability reasons, and then we have also additional 30% of production losses. So on this, and then we were only calculating the roundwood yield, and then we made some calculations. So how much cubic meters we really can gain from the forest. And these are around 3 times 10 power 9 cubic meters per year. And then we made an additional calculation how much carbon dioxide is stored in this material. And we came to a number you may see here. So 2.5 times 10 power 12 kilograms year by year of CO2 can be stored and fixed, and this is around 7% of the annual global emissions. And if you take also into account the avoided emissions, so namely the emissions which are related to the non-use of steel and non-use of concrete, then it's around 10 to 14%. So this calculation is a very rough calculation indeed, but nevertheless, it goes into the right direction. And if you then finally would try to calculate how much dwelling units you can construct by this material, you may see here another very rough calculation. So remember that what I said at the beginning, so the UNEP is estimating that we would need around 2 to 4 billion additional dwelling units by 2050 because of the in-migration into cities alone. So new urban residents. And you see now here, so how much, what we can do with this amount of timber. So in principle, we can construct around 3 times 10 power 7 family houses per year. When we multiply this by 26 years, so at the end we could create or could construct around 2.3 times 2.3 billion dwelling units by 2050, and this is more or less in the range of that what the UNEP is demanding. So in principle, we can do all the construction which we may need in the future on the basis of timber products. But so I was talking most of the time for now on new buildings, but this is not definitely everything. So because we have already a lot of existing infrastructure, and this existing infrastructure we need to improve. And there was an interesting book written by a German architect, which is called Verbietetes Bauen. In principle, in English, that means forbid building. You see by the administration of the Berlin Zoo what this means. So they don't want to ban building industry, building houses, not completely, but they made a pledge for doing the right renovation. And this is one example how this can look like. And you see here the global warming potential, and they applied 3 different scenarios to this building. So a partial demolition plus renovation on the basis of bio-based materials, a complete demolition, but new building, so a new building on the basis also of bio-based material, and then a complete demolition and substitution with a traditional new building. And you see here by this example what this will cause in terms of global warming potential. So the option number one is the most worst one. Yeah, because for this opportunity, you would need a lot of traditional building material, concrete and steel. The complete demolition and the substitution with the timber building still creates some emissions, but not so high as a traditional building. The best opportunity here is indeed to keep the core of the building and to equip it with sustainable materials. So that means, in other words, don't start with the demolishing of all your existing infrastructure. So that's really stupid. Try to make an attempt and to improve it on the basis of timber, of bio-based materials. So how this can look like, you may see here by this very modernistic pavilion, which was used. I have to check it now. In 2019 as a German garden exhibition in Heilbronn, and the building was reused then, namely again in 2023, once again on a garden exhibition, and it was moved from Heilbronn to Mannheim. So that means also when you do buildings and infrastructure like this in the right way on the basis of modules, for instance, you can easily move it from one place to another. So what happens now? Here. Yeah, look, let's finally talk a little bit about the reality. So how we are using timber. We have a misallocation of the materials, indeed. So what you see here by this example is that almost 30% or up to 50% of all the timber products at the end are being used for energy production. That's rather stupid because, as I have shown you, timber is a very valuable material, so we can use it for a lot of different purposes. And when you look on that, what happens on the European scale, you see that even more than 90% of all the timber products end up at the end for energy purposes. And this is something what can be changed, definitely, and should be changed indeed. Yeah. So that means the pledge for using more bio-based materials in city construction would also need to change some existing market mechanisms. And as we all know, changing of market mechanisms are not easy, but nevertheless, so if we really want to make a step towards sustainability, we have to do that. Yeah, and just to make a comparison a little bit between country and your region. So this is Nepal indeed. So I have taken from Saga some data here, and he was providing us some information about forest residuals and logging activities, and he was estimating that the total potential in Nepal is around 80 million tons of timber products per year. But most of the materials is not used for timber construction at the moment. So Nepal has an enormous potential if forests could be managed sustainably. So that's an open issue here. So comparing this with Europe, where we have the certification of forest products up to 90% of all the, or 95% if possibly, of all the forests, and this is just the other way around in Nepal. So this is an area where we can improve things. But if you compare this with the forest yields in Germany, so we are in the same range. So when it comes to round wood, we are also taking out of our forest around 80 million cubic meters of products. And if you would calculate this, if you would use all these materials in house or dwelling construction for construction purposes, you can build around between 600,000 and 700,000 dwelling units year by year, which would then probably store between 35 to 40 million tons of CO2. This is really a success story. Okay, so what does it mean when we talk about circularity? So I will come to an end now. Circularity means in principle, and this is hopefully what I have shown you a little bit by the example of the construction industry. Circularity means that we have to understand the life cycles. So I have shown you that in the moment still huge amounts of timber are not used adequately, so we are burning it, or for heating our homes, or burning it for electricity production. So that's really stupid indeed. So we have to recycle materials. So if we cannot use it anymore, so we have to decompose materials and then seek for ideas how the materials can be reused. But we have to think also in terms of new materials and also establishing sustainable value chains. And for forest and timber projects, indeed, this might be possible, as I have shown you earlier. So this is something what we have to do in the future.